So number 4, the function f is defined by fx, see, modulus x minus 3 for the domain. So this is the domain. So sketch the graph of f and state the range of f. So sketch the graph. So we see here x is from -1 to 7. So we can get 2 points. So we can get 2 points, which is x is equal to -1. So here when x is equal to -1, so fx we know is equal to y. So y is equal to modulus -1 minus 3. So we get -4, which is equal to 4. So the second point until 7. So x is equal to 7, y is equal to 7 minus 3, which is equal to 4. Modulus 4, which is equal to 4. So this is -1, 4, and this one is 7, 4. So we see here we have modulus function. Wherever we have modulus function, that we know that everything for the modulus, it will always be 0. So negative will become positive, and positive of course positive. So we know before negative going to positive, there must be 0. So we should check if there is 0 in the in between -1 to 7. So how to check? So at 0, so we know 0 is on the x-axis, so y is equal to 0. So to get this graph, so first we check the value of x from x to x, and then when y is equal to 0. So when y is equal to 0, so here we get x minus 3 is equal to 0. So when this one is 0, so x minus 3 is equal to 0. So we get the point, which is x is equal to 3. So here we get point of 3, 0. So we have 1, 2, 3. Now we can sketch the graph. So here, alamak. So -1 to, so here -1, 7. So alamak, tak ada warna. So here -1 might be here. So -1. So 7 might be here. So this one is 4. So we have -1 and 4. -1 and 4 is here. So 7 and 4 is here. And then we have 3, 0. So 3 might be in between here, which is 3. So this is 3, 0. So this is our graph. So find the range of f. So f is from the minimum to maximum. So from the graph, we can see that f, the lowest value of f is 0. So here y is equal to 0 up to y is equal to 4. So this is the range of f. So this one is function f. So B, find the range of values of x such that fx is smaller than 2. So when fx is smaller than 2, so we have fx is equal to modulus x minus 3. So x minus 3 is smaller than 2. So we know when we open the modulus, it can be positive or negative, because we know that negative 2 is equal to 2. So 2 is equal to 2. So when we open the modulus, it can be either negative or positive. So when we open the modulus, x minus 3 is equal to 2 and negative 2. Because this is 2, so 2 and negative 2. So we can do one by one. So we do this one first. So x minus 3. So you see here larger than negative 2. So x is larger than negative 2 plus 3. X is larger than 1. So in this case, x minus 3 is smaller than 2. So x, we move here, is smaller than 2 plus 3 is 5. So we can see that x is larger than 1, x is smaller than 5. So x is in between 1 and 5. So see, on the same graph in part A, okay, we have this graph here. Sketch the graph of y is equal to 2x minus 3. Hence, obtain the value of x such that, okay, this is the equation. So, sketch the graph. So, y is equal to 2x minus 3. So, we can do the at the axis. So, when x is equal to 0, y is equal to negative 3. So, when y is equal to 0, so 0 is equal to 2x minus 3. So, here 2x is equal to 3, x is equal to 3 over 2 or 1.5 lah. So, here we have this point which is 0, negative 3, and here is 0, and here is 1.5 and 0. You can take any 2 points, just substitute from here the point that you can mark on the graph. So here 0, negative 3, so 0, negative 3, so below here negative 3, so 0, negative 3 is here, and this one is 1.5 and 0. So 1.5 is in between 0 to 3, which is here. So you can mark the straight line here. So obtain the value such that this 1. So here x minus 3 is equal to 2x minus 3. So to find this equation, we must remove the modulus. We know that when removing the modulus, the value might be negative or positive. So it can be x minus 3, when we open the modulus, it can be positive, which is positive 2x minus 3, or it might be negative, which is x minus 3 is equal to negative 2x minus 3. So in this case, we bring x here, 2x minus x is equal to x. So here negative 3 plus 3 is equal to 0. And in this case, so here x minus 3 is equal to negative 2x. So negative times 2x is negative 2x. Negative times negative 3, we get positive 3. So we bring 2x to the left to become positive. So 3x is equal to, so 3 bring to the back, we get 3 plus 3, which is equal to 6. So x is equal to 6 divided by 3, which is equal to 2. So we see here we have two value of x, which is x is equal to 0 and x is equal to 2. But if we see from the graph, it is not possible for the x to be 0. So you see here this one, the intersection is more than 1.5, in between 1.5 and 3. So this is the possible answer, which is x is equal to 2.